So this talk is called Light Slower in Material Mediums. It's an issue that sometimes confuses people. How can light speed be constant, that meaning in vacuum, and slower in material mediums? Surely they reason the light going slower in material mediums means it has variable speed, which would be contrary to all this talk from Einstein's relativity that light speed is constant. So I'm going to put aside the issue whether I think that light speed constancy has been misunderstood and been dealt with in my other videos, and go with this one. So this is the magazine I will be referring to. It's a popular science magazine and it's responding to a reader's letter. The letter says, I would like to join the discussion of how heat produces mirages, and that's from an earlier letter. You explain that light travelling through dense medium excites the molecules therein, causing them to radiate light energy. The time lag involved in the molecules being excited and emitting a new photon effectively slows down the entire wave packet. If this is the case, then what accounts for the strange phenomenon of the beam of light resuming its original speed after leaving the medium through which it has travelled? So the people at the magazine reply, in modern quantum mechanics, light is thought to be composed of particles called photons that always travel at the speed of light in a vacuum, and that is denoted usually by the letter C, and they miss out saying that. When a photon strikes an atom, it is absorbed, causing one of the atom's electrons to jump to an unstable higher orbit or energy level. So another way of thinking of it is an energy level or an orbit. When the electron falls back to its original more stable orbit, a new photon is emitted, also travelling at the speed of light, and they mean the speed of light in vacuum C. In a dense medium, and it refers to a diagram, a photon is likely to strike more atoms, causing more delays than in a sparse medium. Thus a beam of light takes longer to travel through, although its photons travel at the speed of light. When it emerges, the photon faces fewer delays. So this is the picture the magazine gives. Light comes into the dense medium, is absorbed by various atoms, and then gets re-emitted. But what you note is it comes in one direction and just keeps carrying on in that same direction. Just based on the pictures, I don't think that I'm convinced by it. Light being absorbed and re-emitted, but continuing in the same direction as it enters a material medium. However, earlier article by the magazine does give more detail, but it's supposed to explain why light travels slower in material mediums. As it gets absorbed, then there is a time delay before it gets re-emitted. So I think I want to go to that earlier magazine. And this is the earlier letter, and it says, to the editors, the most exciting news of the June issue was modestly hidden away on page 28. Surely modern physics is in an uproar. Einstein has been dethroned. I refer of course to the article titled How Heat Produces Mirages, which asserts light travels faster in warm air than in cold, pray tell how much faster? This letter is by a person who seems to not know about refractive index and thinks light speed being different in different material mediums violates special relativity's light speed constancy. This is what Wikipedia says about refractive index, and as you can see, you've got an equation V equals C divided by N, and V in that equation is the speed of light in a medium, while C is the speed of light in vacuum. And the speed of light in a medium, a material medium, is different to the speed of light in a vacuum. So the speed of light being constant in special relativity is supposed to be referring to light speed in vacuum, which is C, and that's different to light speed in different medium, where that light speed is not equal to C. Back to the Science Digest magazine, and another reader letter is being confused about light speed. It says to the editors, "The speed of light is a constant. I like to believe that what I read in science books and magazines is valid, but such incongruities make it difficult." And then the Science Digest replies to these letters. Modern physics states only that light travels at a constant speed through a vacuum, but when it passes through a material medium, it travels more slowly depending on the density of the medium. And it refers to this person as Dr. Victor so-and-so, and who says, when light passes through a material medium, you effectively have new sources of light. You're exciting molecules of matter to radiate themselves. The time lag, time delay, involved in the molecules being excited and emitting a new photon effectively slows down the entire wave packet. And it refers to an article in that magazine, which we'll now go to. This is the article referred to. When light and matter collide. What happens when light runs into a hunk of matter? This question was submitted by the 9th grade science class in Akron, Ohio, with the guidance of their teacher. What follows is the class's lucid explanation of some complex interactions usually described by scientists in sophisticated mathematical terms. Light can be thought of as waves of energy moving away from a source such as a candle, but one can also think of it as being composed of discrete packets of energy called photons. The photon concept can help explain why light is absorbed by some substances, is reflected by others, and travels through yet others. And it continues, when photon meets an atom in an opaque substance, the photon is absorbed. This causes the atom to vibrate and dissipate the photon's energy as heat. Since the substance completely absorbs light without releasing photons in return, it appears opaque. When a photon strikes an atom in reflective substance, again its energy is absorbed. In the process, one of the atom's electrons jump to a higher energy level and then quickly return to its original state, releasing excess energy or light by emitting a new photon. This light is what we see bouncing off shiny metal. But in a transparent substance, when a photon contacts an atom, The atom's jumping electron releases a photon that is identical to the original photon and travels in the same direction. The new photon will emerge on the other side of the substance as if it were the original one passing through, the only difference being a slight loss of speed. The substance therefore appears transparent. In reality, very few substances respond to light in only one of these ways. A substance that's transparent, for example, is actually absorbing and reflecting some light as well. So this is the picture showing what's happened. You can have an atom which can absorb the photon, and you can have one which is reflecting the photon, or you can have one which is transparent for the photon. So conclusions are, the article does not go into sufficient details, i.e. does not supply the mathematics, but it provides a rough idea of what's supposed to be happening with light. Supposedly it is light travels at light speed c, and then it is absorbed by an atom, and then there's a time delay before it's emitted again at speed c. And that's explaining why light travels at a different speed through material mediums to what it travels at in vacuum. It's really travelling at the speed c all the time. It's just a delay caused by being absorbed and re-emitted. So that's the end